Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today, we're going to tackle Scala. You've probably heard of it, especially if you're around big data or back-end development circles.
Yeah, it pops up quite a bit.
It does. It's this programming language that kind of blends different ideas together. So our mission today is to really understand what makes Scala unique, where it shines, using insights from an introduction to Scala. Ready to jump in?
Absolutely. So the origins are pretty interesting. It came about back in 2004. Martin Odersky.
Right.
And the whole idea really was to bridge two worlds. Object-oriented programming, like you get with Java, and functional programming. Kind of aiming for the best of both.
Okay, so not just picking one, but trying to weave them together. That makes sense.
Yeah.
So what defines Scala? What are its core traits?
Well, first off, it's statically typed.
Which is good for catching errors early, right? Like a spell checker for code.
Exactly. But the big thing, as you said, is that it genuinely supports both OO and functional styles. You can lean one way or the other, or mix them.
And it runs on the JVM, the Java Virtual Machine.
Yeah, that's crucial. It means you can use all the existing Java libraries, tools. The whole ecosystem is open to you. You're not starting from zero.
That's a huge plus.
Definitely. Plus, it's known for being, well, concise. You can often express complex ideas with less code than, say, Java.
Right. Less code often means easier to read, easier to maintain down the line. So why pick Scala then? That Java interoperability must be a massive draw.
Oh, huge. Access to that massive Java library world is a game changer for many projects. And the expressive code, like you mentioned, it helps with clarity.
And the functional side, that's where things get really powerful for certain tasks, isn't it? Like handling lots of data concurrently.
Precisely. Functional programming encourages things like immutability.
Meaning data doesn't change once created.
Yeah, basically. Think of it like puzzle pieces that keep their shape. In systems doing many things at once, this avoids a lot of complex bugs, where different parts try to change the same thing simultaneously. It makes parallel processing much safer and often simpler to reason about.
Okay, I see. And it has other functional features too.
Oh, yes. Things like pattern matching, which is a really powerful way to handle different kinds of data structures, and higher order functions treating functions themselves as values you can pass around. Very flexible. And that strong type system we mentioned, it really helps build reliable software.
So where are we actually seeing Scala being used out in the wild?
Well, the big one is definitely big data. Apache Stark, a major processing engine, is actually written in Scala. That tells you a lot.
Wow, okay, so it's foundational there.
Yeah. And you also see it in back-end web development with frameworks like the Play framework, also in building distributed systems, things that need to be really resilient and handle lots of concurrent users. The Akka toolkit is a prime example there.
Finance too, I gather.
For demanding systems, that's right. High-performance, fault-tolerant systems, places where reliability and speed are paramount. It's definitely not just an academic language.
But it's not all smooth sailing, I assume. Are there challenges?
There can be, yeah. The source mentions the learning curve. Because it's rich, combining OO and FP, it can feel a bit steeper for newcomers compared to maybe just learning Java initially.
More concepts to wrap your head around at once.
Exactly. Also, compilation times. Turning Scala code into runnable code can sometimes take a bit longer than with Java, especially for larger projects. It's improved, but it's something people notice.
And I suppose with powerful features, you need to use them carefully.
Like any advanced tool, right? You can sometimes make things overly complex if you're not mindful. It requires a bit of discipline.
Makes sense. So looking forward, what's the outlook? Is Scala still growing?
It seems pretty solid. The language keeps evolving, actually often towards simplification and better performance these days. And given how critical big data and scalable systems are, well, Scala's strengths align really well with those trends, so its relevance seems likely to continue.
So who should be looking at Scala?
Yeah.
Who benefits most?
Several groups, really. Java developers wanting to explore functional programming find it a pretty natural step. Data engineers, using Spark, obviously.
Right. Almost essential there.
Back-end developers building those scalable reactive applications we talked about. And, generally any programmer interested in modern, powerful languages that run on the JVM.
Okay. So wrapping it up, Scala offers this powerful blend, the JVM's stability and ecosystem, plus the expressiveness and safety features of functional programming. It lets you write concise, robust code, particularly good for complex, demanding jobs like processing huge data sets.
Exactly. Which leads us to a final thought for you listening. As data keeps exploding and the need for truly scalable systems grows ever more urgent, how do you think a language like Scala, with its particular mix of features, might influence the next wave of software you use or even build? Something to ponder.